Okay, let's put some words to this process now. We're going to kind of attack problem number 7. Number 7 says, suppose that the walking step lengths of adult males are normally distributed with a mean of 2.4, standard deviation of 0.3 feet, and a sample of 34 men's step lengths is taken. We're going to find the probability that an individual man's step length is less than 2.1 feet. Let's kind of put a picture to this and wrap our heads around it, okay? So it's normally distributed, 2.4 is the mean. We have his step length is at 2.1, and we want less than that. Now here's the other thing to consider, okay? It's an individual man's step length. So remember when I was circling and boxing over here? An individual man's step length. That's just your regular z. X minus mu over sigma. We love that guy. So we're going to go z equals x minus mu over sigma. X is 2.1. Mu is 2.4. Sigma was 0.3. This is negative 1. So negative 1 is our z. We're going to head over here to the table, and at negative 1.0, wrong line, negative 1.0. Here we are, 0.1587. 0.1587 is the same thing as 15.87%. I think in the Hawks system, when you do your homework, it wants it as a decimal. This is just giving meaning to it. The chances of you going out and grabbing some random person off the street and taking his step length and it being less than 2.1 feet is, well, there's like a 15% chance. Okay? So that's what that means. Let's change that up. I want you to see the difference here. Same thing. Find the probability that the mean of the sample taken is less than 2.1 feet. The sample this time. So I have my distribution. The mean is 2.4. The sample length mean is 2.1. That means this is mu sub x bar. So this has changed. We're not using the old formula. This is for, oh brother, here we go, the sample. So we're going to use our new formula, okay? So here goes. For my z, I have x minus mu, x bar minus mu over sigma over square root of n. X bar is the sample mean, 2.1, minus mu, which is the population mean, sigma, which is 0.3, the population standard deviation, and our sample size. All right, so we throw that in the handy dandy calculator. I swear I just did this. Yeah, okay. Which makes a z-score of negative 5.83. For negative 5.83, let's go to the table, shall we? Look, it's off the grid. Do you remember what off the grid means? It means 0.0001 is the area here, okay? Which is about a 0.01% chance. What just happened? If I randomly go out and grab 34 men and I find the average step length, there is a 0.01% chance that the average of the group is less than 2.1 feet. See the difference? All right. Last shot at problem 7. So This time we're going to find the probability that the sample mean differs from the population mean by more than 0.06 feet. I'd like to draw you a picture again. Here's 2.4. What does that mean? Differs from the population mean. Here's your population mean. I'm going to differ from by either being more than 2.4 by a difference of 0.06 feet, so 2.46. Or I could be down here 0.06 feet, which makes it 2.34. I want to differ by more than that difference. More than that difference away. More. Out. Okay? So I'm going to find the areas of these two pieces under the curve, and then we're going to combine them together. I want you to hit pause and go and find those real quick. I want you to find your z-score, go find your areas, and put the areas together. So hit pause and go try it out. Alright, for my z-score for 2.34, I'm going to subtract my mean over sigma over square root of n. This gives me negative 1.17. This is an area of 0.1210. For my other z-score, 2.46 minus 2.4, 0.3 over square root of 34. The z-score there is 1.17. I want to point something out to you, okay? I want to save you from having to do a lot of extra thinking and working and problem solving. Take a look at this. This is symmetric. It's normally distributed, okay? Which means that if I go the same distance away from the middle, that these areas will be the same areas. So if I go look up 1.17 in my table, and I do the whole 1 minus jazz, this area turns out to be the same as this area. So if I go look up 1, which is easy to look up, it gives me the other one, which is harder to look up. I need both of those, so I'm going to add the two together. And that gives me a grand total of 24% chance. Okay? Alright, we're going to do that one more time. Problem 29 looks like this. A large bakery sells a mean of 11 dozen cookies per day with a standard deviation of 1.1 dozen cookies per day. Don't worry about it's measuring in dozen cookies, okay? Just consider it as 1.1 and 11. Consider the mean number of cookies sold per day in March, which has 31 days, of 1 year. What is the probability that the mean differs from the population mean by less than 0.5 dozen? The reason they said it was 31 days is because I needed at least 30. Yay, we're good. Alright, let's draw a picture of this situation. I've got a mean of 11, a standard deviation of 1.1. Here's n, and I'm differing by less than half a dozen, which means I'm going to go on either side of the mean by 0.5. There they are. And I want to differ this time by less than a half a dozen. That means, woo, less than half a dozen. Okay? Alright, we're going to go and find the z-scores for these two guys. You can hit pause and find your area yourself, and we'll come back and see if you got it right. Okay, I'm going to go 10.5 minus 11 over 1.1 over square root of 31. You know where those all came from? That gives me a z-score of negative 2.53. The area for that, this area, is 0.0057 from the table. My other z-score is 11.5 minus 11, 0.1 over square root of 31. This is 2.53. Guys, it's symmetric. Of course it is. If I go look it up on the table, it will tell me this area is 9943. Remember what I do with these two areas? Subtract. Alright, so I'm going to subtract those two areas so that it takes the big area minus the little area and leaves the middle behind. And I get a grand total of 9886. What just happened? That means there is a 98.86% chance that the mean the average dozen cookies is between 10.5 and 11.5 dozen. Basically, there you go. It's been a long day and my words are not working. Alright, so 98% chance that it lies between 10.5 and 11.5. Shoo! Nice. Alright, gang, you're doing 7-2 in Hawks also, so that it can check you and give you immediate feedback so that you'll know if things are going well. Alright, we are going to meet up in the chat. You can always come and find me at 1 o'clock also. We'll see ya.